Don't worry. We'll talk too much and then we won't be able to.
Okay, so we're second last unit. We are learning about systems of equations. So linear and quadratic systems.
Oh, I love my painting.
And also, so we're going to start with these systems. That's the first part. Part 2, we're going to look at inequalities. So, Reese, are you going to make it?
Huh?
Inequalities, these signs. Oops, other way. So we're going to look at inequalities. So this lesson we solve systems of linear and quadratics and quadratic equations. So remembering what the word solve means. Anyone remember what the word solve means? Find the answer. Usually it's an X.
Solve for X.
So if we are solving a linear quadratic system, we look at this on a graph. Linear would be what? What kind of graph would that be?
Line,
just
straight.
a line, a nice straight line. And a quadratic, what are those?
The weird thing about like.
The weird things.
I don't remember.
We called them parabolas. Some of us did.
Oh no, those things.
Parabolas. Sometimes we pronounce them parabolas. Sometimes we pronounce them parabolas. Kind of just depended. So these things, the frowny ones, they're good representations of the trajectory a ball thrown at an angle would take, or any sort of projectile. And what would our solutions be here on this graph? It's where they hit each other, where the two equations or graphs hit each other, both the x and the y. So we're going to look at linear quadratic systems. And in lesson 2, one example log. Process is still the same. We're going to look at quadratic. So 2 quadratics. Maybe we've got smiley quadratic meets an unhappy quadratic. And again, our solutions would be where they intersect. So with these, we could have 2 solutions. We might have 1 solution, or we might have no solutions. Just like in grade 10. If you think way back to grade 10, I know that was like a whole 1 year ago, when we were solving linear. Remember, our 2 lines could have 1 intersection. They could have no intersections. If they were perfectly parallel, they would never hit each other and have no solutions. Or with our lines, we had a unique case where they could be the same line and have an infinite number of solutions. So we're going to look at the different cases. So if you remember last year we solved these graphically, which was kind of nice. You could see the picture. Your calculator gave you an answer. We did them algebraically last year as well. So we're going to look at our 2 methods, solving them graphically, which are kind of what these nice little pictures show, and solving them algebraically. So far, so good? That's our little intro. So we're looking at linear quadratic systems first. A linear quadratic system of equations is a system in which one of the equations is linear in the form y equals mx plus b, and the other is a quadratic in the form y equals, bless you, ax squared plus bx plus c. So remember, we spent this year, I know it was like way at the beginning, we did spend 2 whole units on quadratic equations. When we determine the values of x and y that satisfy both equations, we have solved. So that's what we're doing when we're solving. We're figuring out the x and y values that are equal at both. So this kind of leads into some things that you may do if you take a calculus class. In order to determine the area of a shaded region in the diagram of our parabola y equals x squared, and the line y equals x plus 6, it's first necessary to figure out the points of intersection. So where do they intersect each other? Right here and right here. So those 2 points will be our solutions. So we should have 2 solutions. So far, so good. So we've got 2 options. Option 1, we can use our graphing calculator. How would we figure out our solutions with our graphing calculator? Put it all in a graph. So how do we do that specifically? Break our steps down.
YX squared plus 6.
Do we put them all in the
No, you
same
separate.
separate equation? So we do a y1 and a y2. So let's do that. So our y1 is going to be x squared. Our y2 is x plus 6. And we're graphing. Looks like this is in our window. Their window is a little bit different. But we can see our 2 solutions. So now what do we do?
Second trace.
Second trace, option 5. And then
The left side of
we can move that over to our first solution and press enter, enter, enter. So our first solution is x is -2 and y is 4. So we need to do that again with the second one. I'm going to get you kids to do the second one on your calculators, following the same steps.
I got 3, x is equals to 3 and y is equal to 9.
That's what Reese got. Did everyone else get that? Anyone else still working on it and needs some help getting that? Nope. So far, so good. So solving graphically, pretty easy. We've been doing lots of that, right? So next we're going to use an algebraic method. There were a couple algebraic methods we learned in grade 10. You've probably totally forgotten them all. Yes? No? Maybe so. So our 2 algebraic methods, there's one of substitution, or we can use elimination to algebraically determine the coordinates of the points of intersection. So these are our 2 equations. And we want to know when one equation equals the other. So in substitution, just like it sounds like, we know that in this one, y equals x squared. So we're going to substitute x squared for y in our second equation. Does that part make sense? So that's substitution method. We'll use pink today. So we've got x squared equals x plus 6. What kind of equation do we have now? It's a quadratic. Nice. So what did we do when we had a quadratic to solve these guys? We put everything on one side. So on the other side we have 0. Which side would it make most sense to bring everything to?
subtract x squared to the right side.
So if we do what Brody's saying, subtracting the x squared, it makes our factoring work harder because our leading coefficient is not 1. Not that it's not possible. We could do that. For me, I like to have a leading coefficient of 1 in front of my x squared term so that I can factor by inspection, because that's faster. So I would be more inclined to minus my x over to both sides and minus the 6. Is that part okay? So we'll have x squared minus x minus 6 equals 0. Now what do we do? Product sum. What's our product? Nice. Making our sum -1. So we want factors of 6 that add up, or factors of -6 that add up to -1. -3 and 2. Those would multiply to 6 and they would add up to 1, or -1, sorry. Perfect. So what do we do with those numbers?
And what are those things you do?
Just arrows and a multiplying sign and an addition sign. What do we do with those numbers now?
We could do like the short way or the long way. I don't know.
We can do the short way. Why can we do the short way?
Because the x is 1.
Perfect. So that's what I mean by factoring by inspection. Because our leading coefficient is 1, we can just take our factors and put them directly into the factors. Are we done? We're usually never done. Do we know what our solution is? Do we know what x and y equal? Nope.
Oh, never mind.
So we're going to use our zero product law. So this unit's kind of some good review, because we want to know what does x need to equal here for this factor to multiply everything to 0. -2 or +3. Okay, this one's a little bit different. When we were solving our quadratic functions before, we were solving for when y was always 0. In this case, y isn't 0 here. So we've also got to figure out what the y coordinates of each of these 2 points are. Does that make sense? Any ideas how we might do that?
Would we substitute the y next to that x plus 6?
Yeah, we would substitute, we know what x is now. We can substitute it into either equation to get our y value here. Does that make sense? So which equation would you prefer? The x plus 6. So when x is -2, y would be -2 plus 6, or 4. And when x is 3, y would be 3 plus 6, or 9. So that's looking a little messy. We could report our solution as ordered pairs. So our solutions are -2, 4, and 3, 9. There's our 2 solutions. Sydney.
What page is this on?
501.
Did you have to do all the work if you already knew? Because you already got the answers. Oh.
So I'm just doing 2 methods.
Oh.
You're right, Sam. These are not different than what we did up here. Just a different method. So if this was a multiple guess question, and I wanted to find the solution, I might choose graphing because it's pretty quick, and there's less chance that I'll make a mistake. If this is a long answer question though, and I specifically say use an algebraic method like substitution or elimination, I have to do part B. So I have to do this in the method we're using now. I could always check my solution graphically though. Does that make sense? Okay, next step is asking us to verify. So we're gonna have to do this twice. Let's verify, we're gonna check or verify our points -2, 4. So we'll do a left side and a right side for our first equation. So the y equals x squared. Our left side does equal our right side. We have to do it again for our other equation. Where our y equals 6 plus x. So y in this case is 4. X is -2. So our left side equals our right side for this equation as well. Does that make sense? We'd also have to verify or check our second solution. So I'm not going to do that work, but I'll just write down that we should check 3, 9. Is that okay? Can we skip a step? Okay, so the solution to our system of equations, y equals x squared, where does this equation equal this equation? We can report it 2 ways. We can say when x is -2, y is 4, or when x is 3, y is 9, or, so this would be one way to write our answer. Our other way to write our answer is in the ordered pairs, like we wrote above. So 2 options for reporting our answer, our solution. You pick. I understand both. So far, so good? Ready for the next page? Okay, so we got a little note here that in the graphical method, both the linear and the quadratic equation need to be written in the y equals form. When using the method of substitution, the linear equation must be written in the form y equals or x equals. Did you guys want to go over the method of elimination? I guess we can do that with this one. Does substitution make sense as an algebraic method? So we're just taking the what y equals of one and plugging it in for the y of the other. And we can do elimination method on this one. They're pretty much the same. So we're going to investigate the number of solutions. So when we have a linear quadratic system, I'm going to give away the answer. We've got the case where we have this. How many solutions do we have here? 2. We could have the case where we have this. Well, I don't know if that's very good. Let's see if we can. There. How many solutions does this one look like it has? Hopefully 1. So when they're just touching, we have 1 solution. What about this one? 0. So they're never going to intersect. So graphically, it's really easy to see which case we have. Algebraically, our work is a little bit harder. Does that make sense so far? So should we do all of this? Maybe we'll kind of skip a little bit. So I'm going to tell you when we have one solution, it's a special math word called a tangent. And a tangent is when a line just touches a curve in one point. Okay, so we're going to algebraically solve. So we've got this graph shown. That's this one right here. There's that graph shown. We're going to algebraically determine the points of intersection to the line y equals x. So let's do that using elimination this time. I'm going to stack them like this. I'm stacking them so that we've got like terms underneath each other. And with elimination, we're doing just what it says. We're trying to get rid of one of our variables. So in this case, it's usually easiest to get rid of the y. So I have a positive y here. If I subtract the equation below, what's y minus y? 0. 0 y's. So that's what we're going to do. We're going to subtract. So y minus y is 0. X squared, we've got no x squareds to minus. So we still have an x squared here. And what's negative x minus 3x's? Because remember, this negative is going to distribute. And what's negative 12 minus no other constants? Still negative 12. So that one's elimination. Pretty similar to substitution. We will wind up at the same place.
Distribute the negative though, wouldn't it be positive 2x? You'd be subtracting a negative.
So remember, this is y equals 3x, and I'm distributing this negative, so it would be negative 3x.
Well,
So
is it
now
minus
we're
3x?
adding. Now we're
adding.
Does that make sense? Okay. Yeah, that wasn't super clear. So now what should we do?
Should you factor it?
We should factor it. All right. How are we going to factor this? Awesome. Our product, negative 12. Our sum, negative 4.
How about negative 6 and positive 2?
Negative 6 and positive 2. So we get our factors x minus 6 times x minus 2. Taylor, what's our next step?
You have to do the what it gets, or we don't do it.
No, there's no non-permissible values with quadratics because we're not dividing by these. So we just want to know, do we know what x equals? Do we have our solutions yet? Yeah, so that's our next step. So x is going to be equal to 6. If x is 6, 6 minus 6 is 0. And this factor multiplies everything to 0. And our other solution is x is negative 2.
Is that what you did at the top when you like subtracted the first thing?
Elimination.
Get rid of the y.
Yeah, so this process is called elimination. Because Because usually when we solve something, we just have one unknown. If we have an x and a y, we've got two unknowns. Pretty tough to solve.
And you distributed that in?
Yeah, so we are taking our top equation. We took this equation and we subtracted the lower equation from it. And this was our result. Does that make sense? Okay, what did we do on our first page? We've got our x's. Now we have to figure out what the y's are. So for me, you can pick which equation you substitute these x's into, but which one looks like an easier one to substitute into? This one or this one? Yeah, this one looks way easier to substitute into to find out what our y equals. So when x is 6, y is going to equal 3 times 6, or 18. And when x is negative 2, y is going to equal negative 2 times 6, or negative 12. So those are the two coordinates, or 2 points. So we can report our answer
6 and 18.
as an ordered pair. -2 and -12. Or we can report our answer just by listing x is 6, y equals 18, comma, x is -2, y equals -12.
Wait, so for the first one, so it was y equals 3x. So for you did y equals 3 times 6, but how can you y equals -2 times 6?
Because these are our two solutions. Right, this one here, when x is 6, what does y equal? I'm substituting that 6 into this equation. And our other point of intersection is x is equal to -2. What does y equal there? I can substitute. Oh, sorry. Yeah, you're right. I'm multiplying it by 6, so it should be 3 times -2. Thanks, Ava. Oops, that's right with the pen. So, -6. And then we've got to fix this one. Thank you, Eva. So we could sketch this line. So our intercept would be 0 and our slope is 3. So 2 points here. Connecting our 2 points. Hopefully that works.
Is it concert time?
Hi. Sure. It's just recording our lesson. Okay, so hopefully my line is showing our intersection in the right spots. Kinda.
It looks like that second one there is at like 5.
Looks like it's at like -5 instead of -6. So it should be like this. And this one should be at 6 and 18. So like up here. These are going by. They're going by 1. Okay. So here's 6 and 18. Here. Kind of. So that would be what our graph should look like. So far, so good? Yeah? Okay, I'm going to skip this next one. So this next one will show a tangent solution. We could solve it graphically, but we'll go to the last case. where we have our line y equals 3x minus 24. Because this is also good review. So we're going to do our method of substitution. So just recall, because it's on the previous page, our other equation is y equals x squared minus x minus 12.
So is all this review, or is this method of substitution?
It's kind of review. I mean, we've done substitution and elimination for linear systems last year. It's new in that we're using linear quadratic systems. We're using things we've learned in units before, like factoring and zero product law. So it's newish. Is that a fair answer? Okay. Okay, so we've got this one. Did we like substitution or did we like elimination?
I like graphically.
You like graphically? I like graphically too. But I'm just showing us what it might look like with no solutions solving algebraically. Substitution? Okay. So substitution, we are going to take this one. We've got y isolated. We know what y equals. And we're going to substitute it in for the y of our other equation.
That's all you do for substitution?
That's all we do for substitution. So we've got 3x minus 24 equals x squared minus x minus 12. So Sam, what's our next step?
You gotta get rid of everything on one side.
Everything on one side. Perfect.
So you can do, it doesn't matter what side I go to, because you can do plus 24 on one side and then divide it by 2.
That would be the way I would go. Do you remember why?
Because it's easier and there's no.
Yes, it's easier because to factor, because we've got a leading coefficient of positive 1. If we minus this x squared term to the other side, we'd have to factor by decomposition.
And that's extra steps.
There's extra steps. So we're lazy. We're taking the easy route. So we're doing what Sam says, and we're going to add 24 to both sides. We're going to minus 3x. On our left side, we should have a big old 0. On our right side, we're going to have an x squared minus 4x's plus 12. So what was our next step? Product sum. Product is 12. Our sum is negative 4.
You should try,
So we've got a 6 and a 2. Remember that to multiply to a positive, both of our factors have to be either positive or they both have to be negative. So we'll positive 6 times positive 2 equal negative 4. No. Will negative 6 times negative 2 equal negative 4? No. So that doesn't work. Try again.
can we multiply the whole thing by negative 1? You allowed to do that?
That would we'd still have the same factors.
Oh, it was backwards. Because it was negative 12 and positive 4.
No, no. So if we have negative x squared plus 4x minus 12, what's our product? No, it's negative 1 times negative 12. It's still positive 12.
Yeah, that works. Negative 6 and negative 2.
No, because it'll times to no, it'll times to positive 12, but it'll add to negative 8.
We're going to focus on this one. Can we come up with any factors that work?
Yeah,
3 and 4.
Okay, let's list them all.
But it's 62.
3 and 4, 12, and 1. Those are it. Will any of those, if they're both negative or both positive, ever add to negative 4?
Is it
No.
not possible?
So this is not possible. Does anyone remember how we factor these when they're not possible?
You just do a big old N and a big old
No.
say
No, we don't do a big old N and a big old P anymore because we learned a special formula.
There's so many impossible.
Oh, you use the quadratic formula.
Yes, we use the quadratic formula. This sucker, x is equal negative b plus or minus square root, b squared, not 6 squared, b squared minus 4ac over 2a. Did we like this one? Super duper awesome. Really fun. So this isn't factorable, but doesn't mean that we don't have a solution.
What are your, oh, never mind.
So what the heck is my A, my B, and my C? What does all that mean?
Your B is -4 and your C is 12.
So remember, the thing in front of the x squared term is the A. The thing in front of the x is the B. And the thing all by its lonesome is the constant or the C. Bless you. So Sydney's talked about our A is 1, our B is -4, our C is 12. So now we're going to sub them into this hideous looking thing. So negative times -4 is +4 plus or minus the square root of -4 squared minus 4 times 1 times 12 all over 2 times 1. 4 plus or minus 16 minus 48 all over 2, which is 4 plus or minus root 30 -32 over 2. Now, Brody.
What?
Now,
Now.
we are at here. Is this possible?
Yes.
Is it?
Yes.
Put this in your calculator.
No, you can't root a -32.
Oh yeah. That has to be possible. Oh, you can't.
Well, it's plus or minus, so it's plus.
But what part
It wouldn't
won't
be
our
minus, it's
calculator like?
plus,
The -32 then.
Yeah, this isn't a real number. So,
Now can we multiply the whole thing by -1?
no, now we're done. This has no solution.
So we could just say no solution, but we have to show why.
We have to show why. Let's look at this graphically to see why there's no solution.
The lines don't touch.
So our first equation, Brody, is x squared minus x minus 12. Our y2 is is 3x. 3x minus 24. And let's look at our graph. Let's change our window. I'm going to make my
It doesn't
y
touch
min
zero
smaller. So are these two graphs ever going to hit each other? No, it's not possible. There's no solution. And this math, this algebraic math, supports that. Because our root for this is not a real number.
We already knew that.
So this is not real.
We already
So
knew it wasn't.
we need to be able to do both the algebra, Brody, and the graphical portion of this. Our picture matches our algebra, which is awesome. That's what we want.
Why did we have to do the quadratic equation to get the not possible when we already had not possible?
Because we need to be able to do both.
Because the other not possible was potentially actually possible.
This is also great review, right? We've now reviewed solving our quadratic equations. We've reviewed our quadratic formula. So we reviewed a lot of things. Janessa?
So we used that formula because I was gonna find some, right, that would work.
Yeah.
So is that every try? So there's probably some that will work,
Yes.
and because it's like there will be a solution.
No, so sometimes there will be a solution, right? So we've done these where we've used the quadratic formula and we've gotten a solution, and it's usually a radical number. So if we graphed it, we'd have a decimal, an irrational number, a decimal that's non-repeating and we can't turn into an improper fraction. But Brody, we can still get its exact solution by using the quadratic formula. So far, so good? Okay, so we've just got a little bit of some concluding statements. So if the graph of a linear equation and the graph of a quadratic equation intersect at 2 points, then our linear quadratic system has 2 solutions. If the graph of a linear equation and the graph of a quadratic equation intersect at 1 point, then our linear quadratic system has 1 solution. If the graph of a linear equation and the graph of a quadratic equation do not intersect, then our system has 0 solutions. Awesome.
Quadratic equation just like
A parabola. Yep, an x squared. Okay, so we're going to do our next lesson, as it only has 1 example, and I think we can handle that. No, you cannot. We're going to do the lesson. One more question.
oh, it's very short.
It's very short. It's 1 example. We can do it. I have faith. So we are looking at solving a system of quadratic equations. So our work, 2 of them are curvy. Our work is the same though. We can solve them graphically. We can do a y1 and a y2 and find out where they hit each other. Or we can do an algebraic technique where we do either substitution or elimination. Which we reviewed just moments ago. So far, so good? Brody, you following me? Okay. So we're going to use an algebraic technique. Did we have a preference? Did we like substitution or did we like elimination?
We like substitution.
We like substitution. Okay, so all we're doing for that is we can take what y equals here and plug it in for y in this equation.
Would it matter which one you plugged in?
No.
Nope. Wouldn't matter at all. So we've got a 2x squared minus an x plus 1 is equal to 6x squared plus 7x minus 4. Yeah, we can subtract the thingies over. So we're going to have to subtract them all over. So minusing our 1, plusing our x, and minusing our 2x squared.
So 0 equals 4x squared plus 8x minus 5.
0 equals 4x squared plus 8x's minus 5. So now we've got that case where our leading coefficient is not 1. So this is a good review for our other method of factoring. We're still going to figure out what our product and our sum are. Nathan, what's our product?
The 8,
No,
5.
no, no.
Oh, the 20?
Negative 20.
Oh, God.
So remember for these, your product is going to be these two multiplied together. And our sum would be 8. So we're looking for factors of negative 20 that add up to 8. And a negative 2. Awesome. So now what do we do with that information?
We
Plug it in.
figure out what each one equals when each one is that. No?
Not quite.
0
Squared,
equals 4x squared.
Nice. So we are breaking down, we're decomposing our middle term
2x.
with these two factors. We do 4x squared plus 10x's
I would have went the other way.
minus 2x's minus 5. So the other way is way faster, right?
Like if you flip around the 10 and 2.
Yeah, you could flip around your 10 and your 2.
It makes
Absolutely.
more sense.
Sure. Let's do that. Sydney would prefer flipping them around.
Yes, it does.
It doesn't. You get to the same spot.
Oh,
But that's
yeah, it
okay.
does.
Minus 2x's plus 10x's. Sydney was seeing some more common factors with the grouping this way, but you'll get to the same spot.
How do you do it the other way? Never mind.
You still do it. You still do your common factors. So we're breaking this up. This is where Ms. Russell draws her little squiggly line, and we factor by grouping. So with our first two terms, what is our common factor?
2x.
2x. Leaving us behind with a
2x minus 1.
2x minus 1. With our second two terms, we can factor out a positive 5. Leaving us with a,
2x minus 1.
and now we've got a common factor with both of these new terms. Factor out that common factor. We've got 2x minus 1 was being multiplied by a 2x plus 5. We're getting there. Brody, what does x equal? Need to equal to make this 0.
Would it be 1? Nope. It's 1.
No, it wouldn't be 1. It would be 1/2. Yep, or 0.5.
I wasn't sure if it was confused.
So if you need to do the little mini algebra, you can. So isolating x here, because we want this first factor, we want to know what x in this first factor would be to make it equal 0. So we can add our 1 over, and then we can divide by 2. So what about our other solution?
Negative 5 over 2.
X equals negative 5 over 2. Awesome. Is everyone okay with that?
Yeah.
Okay. Are we done?
No, now you gotta figure out why.
We got to figure out y's. So we've got a little bit more work because
Yay.
our two formulas aren't so nice as our other ones. So let's solve for y. I don't know, maybe the second equation looks a little bit easier to handle. So let's figure out what y equals when x is 1/2. So we're going to sub in that 1/2 for all of our x's. So we've got, this will be 2 over 4, or 1/2, minus 1/2 plus 1. This one's kind of nice. 0 plus 1, or 1. That one wasn't so bad. And our other one, what is y when x is negative 5 halves? So 2 times negative 5 halves squared minus negative 5 halves plus 1. So we've got, this will end up being 25 over 4 times 2. So it'll be 25 over 2 plus 5 halves plus 1, which we could call our 1, 2 over 2. So it would be 32 over 2, which is 16. Nice. So also a nice number. And if that was painful for you, I mean, you can always take the lazy root out and just put this in your calculator. So for your first one, you would have, let's do our second one, because our brackets are important here. We want 2 times bracket negative 5 halves squared minus negative 5 halves plus 1. And the calculator will do all that work for us. So that is an option. All right, give me, how are we going to report our solution?
Ordered pairs.
Ordered pairs. So, Sarah, give us one ordered pair. Good question. Those are our solutions. What x equals, what y equals. Yeah. What is y when x is 1/2? No. Do you want to phone a friend? Okay, Janessa.
Oh, I knew you were gonna say that.
When x is 1/2, what is y?
1.
1. Nice.
How did you know that?
That was all this work that we did here. Oh.
Wait, so then what, are you gonna do the y2 then also?
Yeah, what's our other ordered pair? Because we have two solutions. Negative 5 halves and 16. So this would be the answer that I would draw a box around, circle, a heart, puffy cloud, whatever you want to do to make sure that you've communicated this is your final answer. Nope, not quite. So we're going to look at graphing this because we've got two methods, right? So solving this graphically,
You put in the lines.
we put in the y's. So,
6x squared
Michaela,
plus
give me a y1.
Wait, no, you do the big equation, the big boy equation.
I'm not thinking it. 6x squared is 7.
6x squared plus 7x minus 4. Okay. Y2, Destiny, what's our Y2? 2x squared minus x plus 1.
You forgot the x.
Oh, minus x plus 1. Thanks, kids. There's our graph. Can we see our two solutions? This one up top might be a little bit not quite in our window, so let's make our y max a little bit bigger. No, let's make it 20. Okay, so there's our two solutions, and what do we need to do?
Intercepts.
Intersect. So second trace, option 5. We can do this first. We can do this first one. Enter, enter, enter. Negative 2.5 and 16. Look at that. That's what we got, right? Nice. We can do our second one. Enter, enter, enter. 0.5 0.5, which is the same as 1/2, and 1. Boom. Look at us go. Okay, so that's our lesson for today. I will write up our homework, our assigned homework. So for this one, we are gonna do 1, 2, and 3. So lesson 2, we'll do numbers 1, 2, and 3. Good, 2 and 3. I have to flip back more.
This week, lesson 1 is nothing.
Lesson 1, we're gonna go 1, 2, 4, and 7.